Hello, mathematicians. This is lesson 7.5, linear inequalities. 7.5, so you need to title your paper linear inequalities. Now, just as you have used inequalities to describe graphs on a number line, you can use them on a coordinate plane. So the same thing happens. Now, on a number line, if I were to do x is less than 1, I would have an open circle and an arrow less than. On a coordinate plane for x is less than 1, you're going to go through the 1 on the x-axis. Notice this is the x-axis. I'm going to go through 1, and it is a dotted line instead of an open circle. They kind of mean the same thing. It's not completely filled in. And then you're going to shade everything less than. So it looks the same. See, if you look, they're both at 1 on the x, and then they're both less than. So a linear inequality describes a region of the coordinate plane that has a boundary line. The solutions of the inequality are everything that makes it true. So if you look on here, each point on a dashed boundary line is not a solution. So dashed lines, those points are not a solution. So this point right here, 1, 2 is not a solution. Even if it's on the line, it's not a solution. It has to be in the pink shaded area. So if this point, 1, 3, would be a solution. And you can check that by just putting it in. Is 3 greater than 1 plus 1? Yes, 3 is greater than 2. But if I did 1 and 2, is 2 greater than 1 plus 1? No, 2 is not greater than 1 plus 1. It's equal to. And then here, each point on a solid boundary line is a solution. So this point right here, 2, 0, is a solution to this equation. If I put in 0, negative 2 times 0, 0 plus 4, is 2 less than or equal to 4? Yes, that is a solution. So, graph y is less than 2x plus 3. So what you're going to do is you're going to start at the 3. 3 on my y, this is my y-intercept. And then I'm going to do my rise over my run, which is 2. So I'm going to go over 1, up 2, and I can't really do that. So I'm going to go back 1 and down 2, and then this is my line. And if you notice, it goes over 1, up 2, over 1, up 2. So that's the slope. And then I look at my sign. Well, my sign doesn't have the line underneath, so that's a dashed line, and it's everything less than. So that's why they shaded down. It's everything less than. So rewriting to graph an inequality. So sometimes you will see the problem and it looks like this. Graph 3x minus 5y is less than or equal to 10. Well, you can't really graph this very easily. So what you need to do is to solve it and put it in slope-intercept form, and then you can graph that. So then they went to negative 2, they made a dot, they went over rise over run. So rise 3, run 5. And it's positive. And then I'm going to fill in my line because it has a line underneath the inequality sign. So I fill in this line right here. And then it's everything greater than. So I'm going to go on top. Okay, so here's a real world problem. Suppose your budget for a party allows you to spend no more than $12 on peanuts and cashews. Peanuts cost $2 a pound and cashews cost $4 a pound. Find 3 possible combinations of peanuts and cashews you can buy. So you're going to have your equation, and you're going to have $2 per pound for peanuts, so that's 2x, plus $4 a pound for cashews, so this is peanuts. This is cashews, and I want that to be less than or equal to my $12. So there's my equation, 2x plus 4y equals 12. So then, it has to be less than or equal to 12. You have to solve this So I am going to write it in slope-intercept form. So then I get 4y is less than or equal to negative 2x plus 12, and then I divide by 4. So y is less than or equal to negative 1/2 x plus 3. So if you look here, they did 3 is their y-intercept. They went over 1, down 1/2, and then that's a solid line, and it's going to be everything less than, so then I would shade down. Now look, they only drew a positive graph because I can't have negative 2 pounds of cashews or negative 3 pounds of peanuts. It has to be just positive. So anything on this line would equal $12, and anything in this shaded area would be less than $12. Okay, so shade the region containing 1, 1, the graph below. Okay, so here's the possible for cashews and peanuts, just like I just showed you. So now try this one on your own. Suppose you plan to spend no more than $24 on meat for a cookout. At your local market, hamburger costs $3 a pound and chicken wings cost $2.40. Find 3 possible combinations of hamburger and chicken wings you can buy. So, I have my equation. I'm going to have 3x plus 2.4y has to be less than or equal to $24. So I am going to solve for y. So I'm going to minus 3x. So then I get 2.4y is less than or equal to negative 3x plus 24. And then I'm going to divide by 2.4. Take out my calculator. So y is less than or equal to 3 divided by 2.4 is negative 1.25 plus 24 divided by 2.4 is 10. So now you have your equation. So now you're going to draw your graph. I'm just going to grab one from here. Okay, I'm going to go to 10 and I'm going to make a dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go over 1, down 1 1/4. This is going to be a solid line. So I know that this point right here, 0, 10, is a solution. Now I don't think my line is very good. Over 1, down 1.25. So if you just keep doing that, let's do that, and we could make a way nicer graph. So I'm at 0, 10. Over 1, down 1.25. Over 1, this is not going to be very easy, is it? Down 1, and so that's down to 1/2, and then over 1, down to 1/4, and then over 1, down to 1/2. So there we go. So I could just go over 5, down 4. That would be easier. 1, 2, 3, 4, 5. 1, 2, 3, 4. Much easier. So then I'm going to draw my line. So then here's my points. If I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 works. 1, 2, 3, 4. 4, 5 works. And 0, 10. All of those points work to be less than $24. And that's it for your notes.